Hello everyone, and I'm back in my shed. I'm BC. There's a bit of a talk today about bench grinders and grinding tools, but I've just noticed that the depth of field is not really good here, so I might put my chair around the other side after the introduction and give you a closer up. I just don't have a wide angle lens on this camcorder, I'm sorry. Probably the second most abused tool in the home workshop or even machine shops would have to be the bench grinder. The first would be twist drills. And this poor little thing is worked to death, doing way too much. And also, even though the cheapies are only designed to be stop-starter 6 to 8 times a minute where you burn out the capacitors, these poor things get finishes put on them and they're flogged to death. But such is life. Okay, little cheapies like this, under $200, they can be configured in many different ways. This is just with plain type 1 wheels on it. An aluminium oxide wheel for high-speed steel twist drills, etc. And a 39C silicon carbide green wheel here, 60 grit for tungsten carbide drills, or also tungstens for TIG welding. Now a couple of things with bench grinder wheels. These little machines are made with a rotor that is not just pressed into the, or shaft is pressed into the rotor, but they're usually stick welded on either side and on the same side of the shaft. So the poor old shaft becomes a little bit of a banana. Most of them are like that. Some run very good, some run bloody awful. But one thing with these wheels, they're not usually too far out of balance. If you get a machine that wobbles like hell or shakes like hell, all you do is back the nut off, turn the wheel a little bit, do the nut up again and run it again. You might make it better, you might make it worse. If you make it worse, undo the nut and go back 2 sections in the other direction. Do the nut up again and start it. And you'll find that there's a sweet spot for each wheel. It might take a little bit of mucking around. The first wheel, you'll get a fairly big improvement. The second wheel will take a little bit longer, and then you're trying to undo this nut without undoing the other nut, and it becomes a little bit of a pain. But you can get it to the point where the wheels won't wobble too bad. And that's what you need. First start, get them so they're not wobbling, and then you can dress the wheels and all will come good. But don't forget, I normally start with about 1/4 of a turn, see whether it's better, and then come back to 1/8 of a turn, and then just a little bit. And a few minutes spent each side on the wheels and you can get them running reasonably well. These wheels lend themselves to be dressed with several different items. First one, diamond dresser in a neat little holder. That holder can be put up against the tooth rest, the diamond adjusted, a little bit of fine adjustment with the tilt, and really only useful for getting badly worn out of round wheels flat again. I don't like them that much in an unsupported roll, but just remember when you're using a diamond, don't point it up the wheel, aim it slightly below centre. If you aim above centre, you'll get a hell of a lot of chatter and a bloody awful finish. So aim it just a little bit below centre and keep your tool rest up close to the wheel. Probably my favourite for dressing wheels, DS1 dressing stick, silicon carbide. They're made out of the scrapings off the floor of the manufacturing plant. Very, very hard. For God's sake, wear glasses when you use these. They spray a lot of grain around. They can chip and throw a big segment off. You'll finish up covered in bloody rubbish. And if you should happen to drop it, you'll have 6 dressing sticks. They're very fragile, but they do a fantastic job. The diamond dresser opens the reel right up and makes it very, very aggressive. The dressing stick more or less truncates the grain. So the grinding wheel is a little bit less aggressive. And I prefer that. If you're trying to grind a 1/8 drill, the last thing you want is a grinding wheel that chomps the end off before you even get a fair go at it. So these grinders are not meant for fettling castings or doing hard work. So get them backing around with the diamond, get them flat and reasonably smooth with the dressing stick. There is another option, and I have to grin. This is a bronze matrix with a little bit of diamond dust in it. Same as the masonry cut-off wheels. I bought this on a whim, paid $10 for it or whatever. Absolute piece of bloody junk. It's all bronze matrix and very, very little diamond grain. It does sort of do the job. but you can see it's a little bit shiny on the face. I keep it around for a bit of nostalgia. A little bit on the wheels with these machines. If you're using tool room wheels, 150mm or larger in diameter, you'll see there'll be an arrow or a painted line on a lot of the wheels. Now this normally is the heavy side of the wheel after it's been balanced, and when you load it onto the grinder you normally have that pointing up. And the reason is if there's any slop in the arbor it will come down a couple of thou and that will assist with the balancing. So arrow or painted portion up whenever you mount the wheel, and it does make a little bit of difference in running them. All of these type 1A1 wheels are only meant to be dressed on the periphery. The wheels are not designed to be ground on the side, although you can get away with it a little bit. But the wheels are balanced by either sandblasting the side of the wheel and causing a little dimple, or by vapour blasting grain onto the wheel to load it up a little bit. Now if you dress the side of the wheel you take away all of that balancing act and the wheel will wobble and vibrate. So I suggest just dress across the wheel face, dress a chamfer or a profile if you need it, but please keep off the side of these wheels. I'll just grab another wheel to show you. If you're going to be side grinding on the wheel, such as with a drill grinder, a recessed one side wheel is what you should use. Now it's designed to be ground on the face or on the periphery, and you can dress the working face again and again. Once again, the balancing mark. I've got these for the big drill grinder. I've just been too lazy to mount it. I wanted to get the unit running properly first, which I think I have achieved. These are a little bit dearer, but you get a much wider grinding face, good for big drills or larger tools, and an excellent flat face. Another item I have used for grinding tools, especially putting a radius on, is a 12-inch disc sander that you use for timber grinding. Runs at half the speed it should for metal, but it's usually very easy to set up on the table and get it to work. You can also use these little wheels, straight cup and flared cup wheels. And this particular type of grinder lends itself to a very good tool grinding attachment called the Tinker tool and cutter grinding attachment. Originally drawn up by an English fellow, Mr. Tinker, sold to Guy Letard over in Canada, I think. It looks like a fairly good build. The drawings are cheap, $50 plus delivery, $50 US plus delivery, and there's also a Tinker Junior or a smaller version, and it can do virtually any tool and cutter work that the home shop would want to do. I also put my hand up for the Warden tool and cutter grinder sold by Hemingway Kits over in England. If you want something a little bit better, a bit more sophisticated, a larger tilting table and attachments available for 4-facet drill grinding, etc. More money, but you're getting a much better grinder. Both are also good for taking off the bench and putting away underneath if your real estate on the bench is very valuable. Okay, I'll turn the camera off and get around the other side now. Back again. Now this particular grinder has been with me for about 38 years. It's made in Taiwan, one of the very early cheapies. The big difference with these is they put real bearings in them, and they're still banana the shaft, but they don't squeal and squawk. It's seen ages and ages of use. I'm very, very pleased with my money's worth on this. The big thing is when you go for these thinner wheels, the saw gulleting wheels, obviously the flanges aren't thick enough to hold the wheel, so we made a couple of spaces up, and I left them like that because I don't know what sort of comedy was in my employee's head when he put the thick washers on the outside to space up the original flanges on the inside, but to remind me of him and what he was like, I left it like that. I said in one of the previous videos, the wheels have been on that machine for probably 18 years now and gulleted thousands of annular cutters. So I'm really, really happy with the service life you get out of it. And once again, offhand grinding. That's the holder that holds the annular cutters for gulleting, and you just hold the cutter at the angle of the flute and up into the wheel to gullet it. Very, very easy holder to use, and it's given me damn good service over the years. And that's all I use for sharpening hole saws. Screw the hole saw on, and depending on the pitch, if they're fine pitch hole saws, you come to the skinny wheel. If they're coarse pitch or very pitch, over at the rake angle of the tooth. And all you do is just freshen up the face of the saw tooth. You can usually only do it once, then these hole saws are lost their set. But, you know, charge a fella $7 for a $20 hole saw, you both get a bargain. I think it's a pretty good job. Before I take this grinder away, a little bit on drill bit geometry, and I'll try and keep my big hands out of the way so I don't make a mess for you. When you're altering drill bit points, remember your single edge cutting tool geometry. This is the rake face of the tool. You approach the grinding wheel from the side. If all you want to do is thin the web and not touch the grinding face, just rotate the drill a few degrees and take the cutting edge away from the corner of the wheel. That way you only grind inside and thin the web, and you don't change the rake angle on the face of the wheel. If you want to change the rake angle, have the edge of the lip in line with the edge of the wheel. And if you can appreciate, the amount you move the wheel to the left or right changes the effective rake angle you apply to the cutting edge. So for zero rake, you would be up here, bring the wheel across, impinge the cutting edge on the side of the wheel, and you have a very good drill for brass. You only have to take 1 mil or 1.5 mil off the front, and on small drills I just use a little hand sharpening stone, 320 grit aluminium oxide. I take a minimal amount off, do the work on brass, regrind the drill, and it's back to steel. So just remember, rotate the drill to change how much you want to engage the cutting edge. If you run it slightly anti-clockwise, you will only thin a very small portion in the middle there, and you won't destroy the cutting edge. If you want to change the rake angle, rotate it back down and set the rake angle at what you want. Very, very easy. Bye for now. Don't forget, like and subscribe. Here's a grinder I picked up a few years ago, an old wall down tip tool grinder. Tilting table on the left with a slot in it for a fence. Diamond wheel on that side, and aluminium oxide 46 grit wheel on the right hand side. Used for brazed carbide tools, probably from the 1960s I would say. Runs absolutely dead smooth. It is a really nice machine. And the diamond wheel I came with is probably worth 3 times the $250 I spent for the grinder. But I've run out of bench space. As you can see, it's still down on the floor. But if you can find any of the old girls like this, I would suggest you grab it. They are a really, really well built machine.